Hello and greetings to everyone. We move to the next logical operator. We take a 3, which is implication or conditional statement. Implication, the symbol is as such, arrow, or conditional statement. We make good use of the implication sign in mathematics, especially when we are solving questions. Let's take this down. If x is equal to 3, a conditional statement, then x squared will be equal to 9. If you take 3 squared, it gives you 9. The above statement is a conditional statement, or an implication, which is written mathematically as, this is how we write it mathematically, x equal to 3 implies x squared is equal to 9. And we read this as, if x is equal to 3, then x squared is equal to 9. That is, P implies Q, comma, where P is the statement x is equal to 3, Q is the statement x squared is equal to 9. The implication or conditional statement has operator if P then Q, where P and Q are two statements with P being the hypothesis. The first statement is a hypothesis, and Q the conclusion. The last statement is the conclusion. If P then Q denoted as, this is how we denote it, P implies Q is false whenever P is false, and cure, true. That means the implication is false when the hypothesis is false and the conclusion is true. And true otherwise. Means for all the other cases, it is true. We take example. Given the statements, the first statement P, all domestic animals are good. The second statement Q, a dog is a domestic animal. We have two statements. Our conditional statement or implication P implies Q is if all domestic animals are good, then a dog is a domestic animal. Below is the truth table of P implies Q. First column we have the statement P. Second we have the statement Q. For the third we have the statement P implies Q. P true, Q true, P true, Q false, P false, Q true, P false, Q false. For the first, we have all domestic animals are good. It is true. A dog is a domestic animal. True. The implication, if all domestic animals are good, then a dog is a domestic animal. It is true. The hypothesis is true and the conclusion is true. Next, all domestic animals are good is true. A dog is a domestic animal. False. The implication, if all domestic animals are good, then a dog is a domestic animal. The hypothesis is true, but the conclusion, a dog is a domestic animal, is false. Then this will give us the truth value of this statement to be true. The truth value of the statement is true because the hypothesis is true. The next, all domestic animals are good is false. A dog is a domestic animal is true. The truth value of if all domestic animals are good, then a dog is a domestic animal. The hypothesis is false. The conclusion is true. It simply means the truth value of this statement is false. The next, all domestic animals are good. The truth value is false. a dog is a domestic animal, the true value is false. If all domestic animals are good, then a dog is a domestic animal. The hypothesis is false, the conclusion is false. It simply means the true value of this statement is true, because a false conclusion is drawn from a false hypothesis. This is the truth table for a conditional statement. We move now to the next logical operator, which is the biconditional. Take 4, biconditional. Here symbol looks like the implication, but with two arrows as such. We are going to start by writing this down. If x is equal to 3, then x plus 1 is equal to 4. If x plus 1 is equal to 4, then x is equal to 3. Writing this down, making use of the implication sign, take the first statement, x equal to 3 implies x plus 1 is equal to 4, and x plus 1 equal to 4 will imply that x is equal to 3. Such a statement is a biconditional statement, which is written mathematically as, this is how we write it, x is equal to 3 if and only if x plus 1 is equal to 4. The arrow to the right simply means from x equal to 3, then x plus 1 will be equal to 4. The arrow to the left, the backward arrow, simply means from x plus 1 equal to 4, then x will be equal to 3, i.e. that is P if and only if Q, where P is the statement x equal to 3 and Q is the statement x plus 1 is equal to 4. Take this down. The biconditional statement has operator if and only if, denoted as, this is how we denote if and only if, IFF. For two statements, P and Q, the biconditional statement P if and only if cure denoted as P if and only if cure like this is true when P and Q have the same truth value. That means it is true when both P and Q are true, or when both P and Q are false. And false when P and Q have different truth values. That means when P is true, Q false, or P false, Q true, the biconditional statement is false. We take an example. Given the statements P and Q, the first one P, we have the statement John will plant the crops. We go to Q, which is it is raining. This is the statement Q. The biconditional statement P, if and only if Q, is John will plant the crops if and only if it is raining. This is a biconditional statement of the statements P and Q. Below is the truth table of P if and only if Q. For the first column we have the statement P, the second we have the statement Q, and lastly we have P if and only if Q. Next we have to fill the truth table with the truth values. P true, Q true, P true, Q false, P false, Q true, P false, Q false. The first statement, P is true, John will plant the crops, is true. The second statement, it is raining, is true. The biconditional statement, John will plant the crops if and only if it is raining, is true. Next, John will plant the crops is true. It is raining is false. The biconditional statement, John will plant the crops if and only if it is raining, is false. It is false simply because going back from Q, going back to P, that is, if it is raining, then John will plant the crops. The hypothesis is false, it is raining, and the conclusion is true. Remember, when the hypothesis is false, the conclusion true. For the conditional statement, the statement is false. That's the reason why we have false here. We go to the next. John will plant the crops is false. It is raining is true. The biconditional statement, John will plant the crops if and only if it is raining, is false. It is false if we take the forward statement P implying Q. The hypothesis P is false, the conclusion is true, which implies that the conditional statement P implies Q is false. In this case, since it is false, it simply means the biconditional statement is false. The next, John will plant the crops, is false. It is raining is false. If John will plant the crops, then it is raining. A false hypothesis implying a false conclusion is true. Going backward, if it is raining, then John would plant the crops. A false hypothesis implying a false conclusion is true. Therefore, in this case, the biconditional statement is true. You can see the biconditional statement is true when the two statements have the same truth value, and it is false when the two statements have different truth values. We are done with the conditional and the biconditional statements. If in case you have any worries, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.